Hello everyone, and welcome to another ATRA webinar. Today's presentation is sponsored by Seal Aftermarket Products. Special thanks to Seal Aftermarket for making these webinars free to everyone, including non-members of ATRA. A few days after these webinars have aired, members of ATRA can go to our website and download the video, or non-members can go to the Seal Aftermarket Products website, as you see here on the screen, and download the video from there. Let me play you a short video from Seal Aftermarket Products.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send your emails to webinars@atra.com. We'd like to hear any of your ideas that you would like to have for future webinars, or any questions you have about our webinars. Any questions you may have during the webinar, please feel free to go ahead and text them to me, and I will try to answer those the best that I can. This is the schedule for the rest of the webinars for this year. The next one will be the first week, September 1st and 2nd, on the 948 TE internal components. Go ahead and pencil it in now. This is the dates for the expo this year, October 29th to November 1st. Same place as last year, the Rio in Vegas. Great time to be in Vegas that weekend. It's Halloween weekend. Here is the schedule for the seminars around the country for the rest of this year. And the next one will be in Atlanta this weekend. Hope I see some of my old friends there. Today's presentation will be talking about the internal components of the U660E and the U760E, kind of showing a comparison of the two. They have strategy similarities, like for instance, Toyota introduced the U660 sometime in 2007. They put it in a wide range of models. As manufacturers developed 4- and 5-speed transmissions, they simply added gear train components. They would just add another gear set to an existing design. Now, this is a popular design strategy since it incorporates already existing components. The downside is it also makes the transmission bulkier and adds additional weight. Now, Toyota used this strategy quite a bit as they increased gear ranges and newly designed transmissions. But with the U660, they switched to something similar to a Peltier gear train, which is commonly used among several manufacturers, especially Everyone's more familiar with the Lapeltier gear train in the ZF models. Now, the Lapeltier gear train is a combination of a simple planet gear set and a Ravenel gear set. It uses 2 drive clutches and 3 clutch brakes and 1 sprag. The most commonly known thing about Lapeltier gear trains is the front section of the gear train. It's known for having the sun gear being stationary. You've seen this before where the sun gear is splined to the stator support. You'll also see that on a 6L80 as well. Now, this transmission is a little bit different. Instead of the sun gear being stationary, the sun gear is actually driven by the input shaft. Now, this U660 design is compact. It's more compact than many transmissions with less gears. It's small enough that at first you may think it's a 4-speed the first time you see it. Let's take a look at the bell housings. Side by side, you can see there's a difference because of engine size. The U660 goes behind the V6. The U760 goes behind the 4 cylinders. You'll always notice with Toyota, the larger number ends up going behind the smaller engine. Now, the U760 that we're showing you here is an all-wheel drive unit. And you can see by this section here is where the transfer unit or transfer assembly would bolt up to it. Now, if we look at the top of the bell housings, you'll see that there's an identification number embossed just above the axle on top of the case. And you see right here on the upper one on the left, it's U660E. This is a 2-wheel drive. And then the lower one is a U760E, and then it has an F because this one is all-wheel drive. Now, both transaxle and the transfer oil must be drained when the axles are removed off the all-wheel drive. You'll find a notice or a notification sticker underneath this area of the case. You'll see this sticker under there telling you that you have to drain both the transaxle and the transfer oil before you start pulling the drive shafts or the axles out. Now, for the main case, we're looking at the U660 here, and you can see the identification numbers embossed right near the shift lever shaft. Now, for the main case of the U760, the embossed letters are actually closer to the ID tag at the top of the case, as you can see here. Now, for the back cover, it's a little bit different. The U760 has an embossed number shown below here. On the right, you can see it just says U7, where the U660E rear cover has no ID marks or letters embossed on it. Now, if we start to disassemble this transmission, it's much easier to disassemble it if you set the transmission up with the bell housing facing down on a couple of pieces of 2x4 to help keep it from rocking around on the input shaft. This makes it much easier to disassemble. Now, once we have it on the bell housing, you see here on the 2 2x4s that we're using, the first thing I like to do with any transmission I've never taken apart before, I always want to remove the valve body just to make sure there's no electronic components or bolts in the valve body that could prevent me from removing any of the internal components. So we have 18 bolts holding the pan down to the main case. And once we remove that, we take the 2 bolts out for the filter. And now we can get ready to remove the valve body. Now, you only have to remove 11 of the bolts we're showing you here. This will prevent any separation of the valve body, causing any small parts to get lost during disassembly. We'll get to the internal components later on in the webinar. You'll notice that we list each of the bolts by letter for the different length. And also you'll notice here on the left side there's an asterisk next to the E, this bolt here, and this bolt B. These 2 bolts are actually used for positioning the valve body back onto the case as an alignment before any of the other bolts are actually bolted down. So these are the first 2 that we want to snug up to align the valve body to the case. Now the next step would be to remove the rear cover. There's 14 bolts to remove the rear cover to gain access to the forward direct drum assembly. Now the two bolts that are circled in blue have a lower torque required, and instead of the other ones that you see colored in red. The factory manual specifies that these two bolts, normally they're colored in gold unless somebody's moved them during disassembly or assembly. And these two bolts have to be torqued to 12 foot-pounds instead of 17 foot-pounds. Now once the cover is off, we have two sealing rings back here. And we also have a race and bearing. The race and bearing will go right down onto the support that you see for the rings in the center there, just the way you see it. Now the bolt torque in the area of this case that we're talking about for these two particular bolts, according to factory specifications, is crucial. They don't want to distort or damage the case in any way if they're over torqued. Now we'll also see bolts like this that are going to be identified the same way. They'll be gold in color, and we'll get to those on the bell housing later on in the presentation. Now, once we have the cover off, the forward and direct drum assembly will slide right out as one assembly. It'll come right out of the case pretty easily. Now, it shouldn't be a problem there at all. Now, once we have the drum out, the forward clutch would be the C1 clutch, and the direct clutch would be the C2 clutch. Now the C1 clutch is used from first gear all the way through fourth, and the C2 clutch is used from fourth through sixth gear. Now fourth gear is a 1-to-1 ratio. Now what we want to do is we want to remove the snap ring holding the C2 apply sleeve to the direct drum assembly. So just think of this as think of the C1 clutch as a forward clutch and the C2 clutch as our direct clutch, just like any of the other transmissions we've worked on with the Ravino gear train. And remember, the direct clutch is also used for reverse. So here's what the assembly looks like. We've taken the snap ring off. You can see the C2 direct clutch assembly there. There's our apply sleeve. Now on top of the drum, you have what's called the retainer housing, the return spring, and then you have the molded C2 clutch direct apply piston. And you can see right on the back of the drum itself, we have a seal there also. Now there's 3 C2 direct clutches on the U660. There's only 2 found on the 760. Now we flip the drum over, we take these direct clutches out. You'll notice there is a thrust bearing. We show you where that goes, with the lip facing up. And there's also a rear snap ring that's holding that sun gear in place. And the clutch clearance on this drum should be about 21 to 29 thousandths. There are 6 different flange or pressure plate thicknesses to adjust the clutch clearance. Now with the C2 clutch out of the drum, we have a double snap ring here. We're going to remember this, that both of these snap rings have to go back in. Now we can take the C1 or the forward clutch assembly out, and the clearance for this drum should be about 31 to 38 thousandths. And we have 4 pressure plate thicknesses to adjust the clearance here. And you can see we have 4 clutches on the U660. And we also found that the U760 both have 4 C1 clutches. Now this is an exploded view of the C1 forward clutch assembly. On the right you see the first thing that goes down is the apply piston. That's a molded piston. It should be changed on every overhaul. Then you have the return spring and a balance piston. And you have the snap ring holding that down. Then we have a bearing and race, and then our sun gear, which is the actual C1 clutch hub. And there's our thrust bearing and snap ring. Now, with all the drum assembly out of the case, the next thing that we're going to see is the low one-way clutch, or the sprag assembly. We're going to remove the snap ring that holds the low sprag into the case. And when we remove that sprag assembly, we want to make sure we don't lose the anti-rattle spring. And you can see in the bottom left side of the photo that is where the rattle spring is located. And then we give you a closer view of how it actually sits in place on the right-hand side. Also remember, in the back of the case we have 3 O-rings that seal between the cover and the rear case. And that's your sprag rotation. Obviously the outer race is being held by the case, so the planet should turn counterclockwise. Now if we remove the snap ring, the low sprag, the B2 brake clutch assembly is all-in-one assembly that'll slide right out of there. The clutch clearance for these clutches you see here on the right should be approximately 34 to 47 thousandths. And there's also 5 different flanges or pressure plate thicknesses to adjust the clearance. Okay, the next thing you'll find is when we do remove this, there is a bearing that sits on top of that planet. You can see that it has an inner lip that faces down. You want to remove the snap ring that holds the return spring assembly, and then we can go ahead and take the apply piston out. Now, in order to remove this planet, as you can see on the right, there's a threaded section at the end of it, and basically what we would have to do is get to the front section before we can get that apart. So now we flip the unit over and we start taking the front drivetrain apart. And as I mentioned before, we have 20 bolts that we show you here on the front bell housing, and 3 of the bolts that are circled in blue, the same as what we were talking about before. These bolts only require 17 foot-pounds versus the 23 foot-pounds required for the rest of the bolts. Again, these bolts should also be colored in gold. This is the factory specifications. Apparently they don't want this area of the case over torqued to cause any warpage or damage to the bell housing section. So that's the factory specs for those 3 bolts. Now, we don't need to remove the Torx bolt that you see holding the pump assembly in at this time. Once we lift the front bell housing off, we have our differential. We can just lift that out of the case. Also remember, we have an O-ring here that seals between the bell housing, the pump support and the bell housing. Now we have 7 more bolts that we have to remove here, and then we can remove the pump and stator support all in one piece. Now with all that removed, we want to leave the counter driven gear in. We don't want to remove that yet. We want to put the transmission in the park position. And then with the special socket that you see the Toyota part number for that on the right, I'm sure we can probably search for this on the internet and find it maybe cheaper through eBay or something like that. Once we unstake the output shaft planetary nut, and we also give you the tool number for that, but you can just use a suitable punch. And we also give you the part number for the nut itself from Toyota. It only costs about 12 bucks. That should be changed during every rebuild. And then once we zip the nut off, then we can go ahead and remove the counter-driven gear. And then we can flip the trans back over and now take or just leave the trans there, and we just take a bushing driver that'll fit inside the planet itself, and then we can just lightly tap the planetary out of the bearing. And that's what it'll look like. You'll be able to take the transfer gear off. The bearing is a press fit. We talked about that in the previous webinar on the introduction of this unit. But now this is what it'll look like with all the parts removed. We also have another O-ring here. We want to mention this O-ring again. Once we remove the pump and stator support, you have that O-ring that seals between the case. And again, we also mentioned in the previous webinar, the most common problem we see on the U660 is the outer race will wear into the case, will become loose, and then the case will have to be replaced or repaired. Okay, now that once we have the pump assembly and stator support out, we can go ahead and remove these Torx bolts that you see here. There's 9 of them. We still have 7 more to go on the other side, but we'll get to that a little bit later. We have to disassemble the brake clutches from there first, and I'm going to show that to you right now. So we can go ahead and take these bolts out, and then we go ahead and flip it over. On the other side is our B1 and B3 brake clutch assembly. First thing we have to remove is the thin hooked type snap ring that holds the B3 brake clutch in. The clearance for that clutch is about 23 to 30 thousandths. There's 6 different pressure plates to adjust that clearance. And make sure that when we go back together with this, that the hooked end of the snap ring that you see in this diagram goes back to the same location. Now here we have another double snap ring we have to pay attention to. This gets left out a lot. We did mention this in the previous webinar that it caused any shift issues if one of those snap rings were left out. Now these are 2 regular flat snap rings. We'll go ahead and remove those 2. That gets us to the B1 brake clutch assembly. Clearance for that clutch is about 31 to 38 thousandths. And we have 6 different flanges or pressure plates to adjust the clearance for that. Notice the opening of these 2 snap rings also align with the opening in the support housing. Now that we've removed all that, we can see the last 7 Torx bolts that we have to get to. Once we do that, we can drop the pump out from the other side. Only thing I want to mention here is the 2 dimples that are shown, these ID marks that are shown on the inner pump gear. They have to face upward. You'll be able to see them as you load it into the gears into the pump body. Just something I ran into recently, we found that there's 2 different pump bushings for the U660 transmission. The early one had an outside diameter of 1.820, and then the later one had an outside diameter of 1.858. That's a difference of about 38 thousandths. So obviously if we had an early bushing trying to put it into a late pump, it'll just basically slide in on you. Now the U760 pumps outside bushings, outside diameter is the same as the later U660. They're all the same. Now the inner diameters on all of these bushings is the same. It was just the early U660 outside diameter that was a little smaller. So the only difference between the converter hubs, the diameter is the same. The U760 hub is a little bit taller. All the other dimensions of the pump are the same. Special thanks to Dale and Hester over at Whatever It Takes for helping us out with this information. Another thing I want to show you here is the pump stator support comparison between the U760 and the U660. Now over here on the left, the holes that are in the side of the housing are much larger on the 760. There will be a large hole in the middle, as you won't see a hole on the large hole like that one, on the one on the U660, the one on the right. Also, the one on the right will have a large cutout where the U760 won't. Now you can see where we had scribed in 760 on the casting. That's not normally found on the casting. We just did that for identification. Now I want to talk a little bit about that input sun gear, the underdrive sun gear. It's on the input shaft. But basically, the bearing would go down on the stator support like you see here on the right. The sun gear would sit on top of that bearing, and then the input shaft would slide down in there, and you can see where the input shaft is actually splined to the sun gear. So whenever the engine's rotating, the sun gear and input shaft will be rotating with it. And then there's another bearing and race that sits on top of the input shaft. Now, something I want to mention here is that the tip of this input shaft, you can see this smooth area. We don't have an O-ring or a seal for the converter clutch. So we would normally assume that if there's no seal located on the shaft, that there would be a seal inside the converter to seal the converter clutch. But that's not the case. On this U660, I got a call from Steve Joso over at Sonax that gave me a heads up and these photos, kind of explaining what this converter looks like inside. Now, as you can see, the shaft would come through and the splines would mate right here, and our smooth tip would be actually mating with this area inside this turbine hub. This is the other side of it, and you can see that there's no seal here. So they're using metal to metal to seal the input shaft. Now, this is not normal. This is actually broken. This is the most common problem they're seeing, is the splines don't wear out. The problem is the spline section will actually break off of the turbine. So this is a big problem with this converter. Now, the underdrive planetary assembly, you can see that we already have our sun gear and input shaft sitting here inside of the stator support. We have a bearing and race that sits on top of the planet itself. And then our B1 clutch hub, which is the ring gear to this planet. That will slide right there on top of it and look like this. And then we just slide that right down on top of the sun gear and input shaft that's sitting on the support. And that's your underdrive planet assembly. A little bit about the valve body disassembly. It's always best to remove the harness, the internal harness, and the connections to the solenoids first. As you can see, the speed sensors have a separate plug so they can be removed by themselves. Once we have the harness and the speed sensors removed, and then we can go ahead and remove these bolts holding the pressure plate, the pressure switch assembly and temp sensor that you see here. So remove all the bolts that we have circled here, and now we can get to the valve body. First thing you're going to notice is this is the hole that lines up with the temp sensor, and you'll find one line pressure relief ball and spring. The ball goes in first, then the spring. We want to separate the sections apart. We want to make sure that we move the plate without losing a lot of the small parts inside. Once we've done that, you'll see that we have 3 large steel check balls. We give you the dimensions for those. And we have 1 small rubber check ball. We also identify each circuit that these check balls control. We have 2 filters that face up. The open ends face up. Unlike the earlier transmissions that we've worked with the Toyota, that these filters would actually snap into the hole of the separator plate, these don't do that. They just sit right there inside. Just make sure that the open ends are facing up. This is something we just ran into recently. We got a tech call in that we had a tech working on a 2010 Camry U760, and instead of having the check ball for the line lube that you see here on the bottom left corner, he actually had this tan check valve, little spring check valve with a dark blue plastic bottom to it, and that's what he found in that location. We have on the right 2 more check valves, converter relief and lube relief, and we identify the springs, give you the dimensions for those, because the strong spring goes to the lube relief, and then the converter relief is a lighter spring. So we obviously found that with this new check valve in that location, the hole that you see here in the plate will actually be a small orifice there. So they won't have that large hole like you would have for the plastic check valve. So special thanks to Dan over at C&M Auto in California for helping us out and giving us this information. Like with all transmissions, if we have accumulator pistons, we have to take a good look at these bores and make sure they're not worn. And we identify what each accumulator is for. So if I had a slipping problem with the V2 clutch, that would probably be the first place I would go and look, is at this accumulator bore. He's also given you the spring dimensions in your handout. This is the upper valve body section. We identified all the valves for you. As you can see, we have 2 more accumulators in this section of the valve body. And also we have the spring dimensions in the handout for you. Now the middle section of the valve body, one of the things I want to point out here in the upper left corner, this is the solenoid modulator end plug. You might want to mark that if you do have to take this apart, to make sure that we put it back where we started. It is adjustable, and there's a 1 in 3 chance of getting it in the wrong adjustment setting if you don't mark it before you take it out. Don't forget, this is also the oil that is this controls the oil to all the solenoids, so this is a crucial adjustment here. There's no factory settings from Toyota. Each vehicle model is different, and depending on engine load, so the adjustment may be different on every one you check as you disassemble these. Now on the U660 valve body, we want to talk about identifying them. It's pretty easy. You'll find that this ID mark in here in the upper right corner of the valve body. This is the section that faces down towards the sump or the pan. So it's pretty easy to identify it. This is the U660. Also on the U660, you'll find a pressure switch assembly. There is no pressure switch assembly on the U760. And this pressure switch assembly has the temperature sensor built right in it. What we have run into lately is on some 2011 to 2013 models, no rhyme or reason behind them, but you'll actually find some of them that have 2 pressure switches missing. You'll still have the temp sensor and pressure switch number 3, and the plate will also change. It will have the feed hole for the 1 pressure switch, and obviously the other 2 missing pressure switches, the plate will have those 2 holes blocked off. So we don't want to mix and match these plates. You have to keep them with the correct pressure switch. This information was given to us by Jeff Parley over at Valve Body Express. I want to especially thank him for that. One of the things, we were at one of the valve body rebuild facilities here in Florida, and they were working with this, and they did notice that when you do find the one with the 1 pressure switch, and it is on a U660, you'll find that there's no ID mark on the valve body, just like you would find no ID mark on a U760 valve body. Now, this particular repair shop refers to these single switch valve bodies as U670s, although there is no documentation for that model ID. It's just something that they call them. So they noticed that every one they found that had only 1 switch had no ID marks on it. Although it was a 660, it had no ID marks on the valve body, just like the U760. Some more ID marks embossed on the upper side of the valve body. And you can see this is a U660. The U760 has no ID marks, as we mentioned earlier. There's no pressure switch assembly. And you can see the harness only has the temp sensor. Even on the other side of the valve body, you flip it over, there's no additional identification numbers embossed here either. So the only valve bodies we found with any kind of identification embossed on the casting was the U660E. And if it was a U660E with only one pressure switch, there was no identification markings on that one. Okay, U760, we have an issue with a lot of calls on the tech line with the cross solenoid wiring. So pay close attention to where the solenoid connectors go. It's usually the SL4 and the SL3, only on the U760 that we have issues with them being crossed. The SL3 has a blue wire, the SL4 has a green wire. And the reason that this happens very easily is where the actual plastic ties are, they kind of leave these pretty loose, and they end up getting swapped right here. They end up on the wrong locations. They both have the same color connector on them. We mentioned in a previous webinar on the introduction that these two solenoids should be kept in the correct locations. The snouts are a little bit different, and this can cause the engine to stall because that's the lockup solenoid and the line pressure solenoid. So obviously if they're swapped, we bring the converter clutch on at startup and put it in gear, will stall the engine. So that's a couple of common problems that we see on these units. Now this is the U660 solenoid wiring, and you'll notice here the plastic ties. They kind of keep everything a little more in place. And you can see how the green wire for this solenoid is kept separate completely from these other wiring connectors. And we don't run into that problem on the U660 as we see on the U760. Okay, case air checks. Get the unit assembled, everything's together except for the valve body. We can go ahead here and check all our clutch assemblies. And you have that case air check information in your handout. Couple of differences here we want to talk about. We did cover the service information on the U660 introduction webinar. I just wanted to show a comparison of the different pan configurations. Also with the filters, you can see they're quite different. We don't want to mix these up. And especially here, you can see there's an actual difference in height. Special thanks to Robert Bateman over at SAP, Seal Aftermarket Products, for helping me out with some of these photos and the information for this webinar. Biggest problem we get on the tech line with most of these late model Toyotas, we see this quite often, especially on the A750s and A760 rear wheel drive units, but we also get it with the U series, and that's using the wrong type of fluid. Now this can cause shift flares, harsh shifts, TCC shutter, but the most common complaint we get is the transmission shifts fine, but it seems to be running hot. They'll go through the cooling system, everything's fine there, and for some reason the unit still wants to run hot. Now the comment that we get from most of the shops is the fluid that they're using is the same fluid they've used on the same type of unit before, but for some reason this particular one is running hot. And the fix every time on the tech line has been to use the WS fluid from Toyota. Now you have to remember, everything is designed on that transmission to work with each other. For example, the fluid is designed to work with the strategy of the software to apply a certain clutch material. And one of the things I noticed, I was speaking at a TCRA seminar this year, and we actually went and toured the Koyo thrust bearing plant. And when we went into the testing room, they had all these machines that were testing the thrust bearings. And each machine had a different name on it. One said GM, another one was Ford, Toyota. So I asked them, are you making different bearings for each one of the manufacturers? They said, no, basically it's the same bearing, maybe different dimensions. So I said, then why would the different testing? So basically what happens is Toyota, for example, would want the bearing tested under a certain amount of pressure for a certain amount of time using their fluid and monitoring the temperature. So as you can see, the fluid's also designed to work with the hard parts as well as the soft parts in the transmission. So if you're ever having an issue with one of these running hot, try using the WS fluid. It hasn't failed us on the tech line yet. And that's about it for today's presentation, sponsored by Seal Aftermarket Products. I want to thank you all for attending. I really appreciate your time, and I hope I see you again in 2 weeks. Okay, I see we have a couple of questions. And this one is, on the U760, the LS solenoid have a filter. And the U760 valve body problem, the secondary solenoid, lockup solenoid, modulating valve. So basically, Angelo, you're telling me that you see a lot of problems with this valve body and the solenoids. I would probably say, if I was to do a seminar on any of the Toyotas, and I'm doing one coming up soon on the A760, and you can basically say that the most common problem we see on those is first with the solenoids failing mechanically, not electrically. And these valve bodies from Toyota have always been an issue with wearing out. So appreciate the comments, reminding me to mention that to everyone. The most common problem on all of these Toyota units, A, solenoids having mechanical problems, and B, the valve bodies themselves wearing out. Okay, so if there's no other questions, I'm going to go ahead and end the webinar. If I do end too soon, please just go ahead and send your questions or comments to webinars@atra.com. Again, I want to thank you all for attending, and I hope I see you all in 2 weeks. Angelo, you had a question on the videos. Like I said earlier, if you're not a member of ATRA, you can go right to Seal Aftermarket Products website. We have the website in your handout material. If you are a member of ATRA, you can go to the members section of the website at ATRA and download the video from there. You have to wait a few days after the webinar is aired before the video will be loaded onto the websites. Again, thank you all for attending. Have a good day, and I hope I see you in 2 weeks.